So here we've got two signal dispatchers, D1 and D2, and they're both transmitting constant signals out. And we've got a boat here in the ocean that's receiving these signals. And we can find the hyperbola that this boat lies on, and we can then use that hyperbola to pinpoint this boat where it's located. So because these signals are transmitting at a constant rate, we can use this equation D equals R times T. The difference in the distance from D2 to this boat and D1 to the boat, the difference in these two distances equals the rate that they're being transmitted times the difference in the time that the boat is receiving them. So the rate that these signals are being dispatched is 0.186 miles per millisecond. And this boat is receiving these signals almost staggered because this D1 to the boat is clearly shorter than D2 to the boat. So this boat is receiving them 150 milliseconds apart. This comes out to be 27.9 miles. So this D2 to the boat minus D1 to the boat is 27.9. Now if we draw this hyperbola, and we use this point right here, if we do D2, and we know that all of these points on this hyperbola, the difference from D2 to that point minus D1 to that point is always going to be 27.9, always. And so if we have D2 to this point minus this distance, that's 27.9. But we know that this distance, D1, this focus to this point, and D2, this focus to this point, we know these two distances are the same. So if you subtract, so now we can subtract D2 to this point. We can subtract this main length from this one, and this will give us 27.9. This section right here is now 27.9. And now we also know that from the center here to this point, and the center here to this point, we know that these two distances are also the same. And we know that they are each half of 27.9, and they come out to be 13.95. And now, and these two dispatchers are both, they're 150 miles out from the center here. So we've got A is 13.95, and we've got C is 150. And now the equation for a hyperbola, we can put it over here to remind ourselves: x squared over a squared minus y squared over b squared equals 1. And so, b squared. And so we have a and c here, but we don't have b yet. And to find b, we can use c and a. So we can do c squared equals a squared plus b squared. And we know that C is 150, and we know A is 13.95. And so this now, B comes out to be 149.35. So now we've got our A and we've got our B, and now we can make our hyperbola equation. So we've got x over 13.95. We've got all of that squared minus y over 1 or I'm sorry, 13.95. I'm not sure if I said that. And then now we've got our y over our b, 149.35. All of that squared. This all equals to 1. This is now our equation that this hyperbola is, that this boat lies on.